Hello everyone, I am Kokendra Narendra medics number CE200 from group 11, and this is subject ECAD and I am from section 3. So I will be explaining about our project, which is fourth order bandpass filter. So this is the circuit we have constructed using Proteus software, and this is the actual circuit we have constructed referring to the one we have constructed using the Proteus software. So here, as you can see, this is the components we have used for simulation, and these are the components we have used for actual hardware. As you can see, the resistor we have used for simulation was 18, but for actual hardware there was 22 resistors. So for this is because for R1, R2 and R3, R4, instead of using 159.15 k ohm, we have used 150 k ohm plus with 6.2 k ohm, and also 150 k ohm plus with 10 k ohm. So this is because we cannot find 159.15 k. So instead of obtaining the actual value, we have used nearest value of resistor, and also the same we have used for R5 and R6 and also R7 and R8. Instead of 19.89 k ohm, we have used 20 kilo ohm. And for non-inverting amplifier circuit, we have used 6.2 k ohm instead of 6.1138 k ohm. So here, as you can see, this is the result we obtained from the Proteus software for low cutoff frequency, which is 10 kHz, where our dB was 31 dB. And this is the result we obtained from the actual hardware using oscilloscope. So we have set the Vin to 150 millivolt, and our Vout was 5.833 volt for 10 kHz, 10.471 kilohertz. And for high cutoff frequency, which is 80 kHz, our dB was 27 dB and our gain was 27 dB. And this is the result obtained from the oscilloscope, which is we have used the Vin as 141.667 millivolt, where our Vout we obtained was 5 volt. And this is the center cutoff frequency, which is 28.3 kilohertz, where our gain was 33.7 dB. And this is the result we obtained for the actual hardware for the frequency, for the center cutoff frequency, which is 21.49, where our Vin we have set to 150 millivolt, and we obtained the Vout as 5.416 volt. So from the results we obtained, this is the hardware results, the result we obtained from the oscilloscope. And as you can see, for 10 kilohertz, the Vout was 5.833 and our Vin was 150 millivolt. So our gain dB was calculated using Vout over Vin. So first, when we do Vout over Vin, we will get the gain here, and we have to 20 log this value, and we will get the gain in dB. So as you can see, the 10k hertz, for 10k hertz, our gain dB is 31.8, where our low cutoff frequency for Proteus software was 31 dB. And for 28 kilohertz, like here, as you can see, our Vout was 5.4 and our Vin was 150 millivolt, and our gain dB we obtained was 31.13, where in our Proteus software, our center cutoff frequency was the gain dB we obtained from the Proteus software was 33.7 dB. And for 80 kHz, where our Vin was set to 141.667 millivolt, so we obtained the Vout as 5 volt, and the gain dB was 30.46, where our Proteus software result was 27 dB. So from here, from the table we have obtained the graph. So as you can see, the shape is actually like bandpass filter, and the table is actually from gain to frequency. So for conclusion, if we compare the results we obtained from the hardware with the simulation, so first let's start from the low cutoff, which is 10 kHz. The result we obtained from the hardware was 31.8 dB, while the simulation was 31. And for high cutoff frequency, which is 80k, for the hardware we obtained 30.46, but for the simulation we obtained 27. And for the center cutoff frequency, which is 28.28 kHz, for the hardware we obtained 31.13 dB, while the simulation we have obtained 33.7 dB. So from here, we can conclude that the value we obtain from the hardware is not exactly the same as the value we obtain from the simulation. This is because we can say that due to the value of components we have used for the hardware is not exactly the same as we used in the simulation. For example, as I mentioned earlier, instead of using a resistor value with 159k ohm, we have used 150k ohm plus with 6.2k ohm and also 150k ohm plus with 10k ohm, which makes it 156.2k ohm and also 160k ohm respectively. So this might be the reason behind why we didn't obtain the value for the hardware result exactly same as what we have obtained from the simulation. So that's all from me. Thank you.